Okay, welcome to the session on speeding up machine learning model training using Druid. My name is Vijay Narayanan. I'm a lead solution engineer with Imply. So in this session, I'm going to look at a number of things, starting with where does Druid fit into the machine learning pipeline? Look at how Druid can help in exploratory data analytics. Then look at how Druid can be used to monitor the input and output of the machine learning models. Then briefly touch upon how model training can be speeded up using Druid, and then go through three demos, starting with training a simple regression model to predict a numerical value used for a clickstream data set, specifically to predict conversion rates. Then look at a ARIMA forecasting model for stock data, and then look at a logistic regression model where a categorical variable needs to be predicted. So these demos will give us a sense of the different advantages of using Druid when trying to use models, train models on very large data sets. So where does Druid fit into the broader machine learning pipeline? There are three areas that Druid really fits into the machine learning pipeline. The first is exploratory data analytics. Right, exploratory data analytics refers to understanding your data in multiple different ways to figure out what attributes of your data, what columns you want to use for training a model, figure out whether there are highly correlated attributes. Obviously, highly correlated attributes don't give additional information to the model, but bloat up the training data. And also look at how different metrics behave at different granularities. These are the kind of things one would do in exploratory data analytics, and this is an area where Druid helps when you're dealing with a machine learning pipeline. Now, monitoring model input and output is also very strong use case with Druid. There are many tools that actually monitor the models themselves, how the models are working, various performance counters for the models, and so on. Here we're talking about looking at the model input and output. The data that's usually most of the time streaming into a model, especially if you're doing a real-time prediction. You want to look at the model input and output and detect anomalies in the model by detecting anomalies in the input and output. Now, sometimes the model itself may be working correctly, but it's perhaps your input is having anomalies, in which case the output also will have anomalies, and inputs can have anomalies because some upstream process, maybe you're receiving data from your customer and running machine learning on that, and that upstream process has got some issue which is creating anomalies. So there are many reasons why models may start misbehaving in the real world, and monitoring the input and output allows us to do that. And you can also detect issues with the upstream pipelines. And lastly, of course, the most important, training the model. Here, the whole question is, how do I get usually a smaller amount of data from a very large data set in the data, like often billions of rows, but you're not going to use billions of rows for training. You probably need a few thousands, maybe at the most few 100,000 rows for training models. And then, of course, being able to train on different dimensions and metrics. And also vary the number of data points based on training requirements. So for example, if you are training a genetic algorithm, you really need a large amount of data points because genetic algorithms essentially assume each data is a gene and then go on a generation by generation natural selection type of algorithm. So that requires a large amount of data points to start with. So let's get a little more detail into each of these three and how Druid helps. So one of the things you often do in exploratory data analytics is identify the number of rows with null values in categorical attributes and drop the null values in training data. Why do this? It's because most machine learning models do not do well with null values. So it's a requirement to drop it because they don't actually help you in any useful way in making a prediction. And as we all know, getting rid of nulls can be a very fast operation in Druid because it is a filter operation, and which is a bitmap operation in Druid because a bitmap index and tends to be extremely fast. And then one of the other things is identify patterns in your categorical variables, different types of patterns. Sometimes you may have only 4 or 5 values, and you want to see row counts for each of those values so that to make sure there is no skew in your data, because skewing obviously affects your model predictions. So that is another thing that's very easy to do in Druid because of fast aggregations. In terms of numerical data, especially metrics, you want to compute mean, standard deviation, variances to basically identify and eliminate outliers. Again, outliers are not very useful because they tend to cause overfitting in models, and hence the model does not work very well in the real world. And again, here Druid helps a lot because you can compute statistics on petabytes of data very fast. And the other interesting thing is being able to aggregate at different time granularities. This is very useful when we're doing forecasting, any kind of forecasting. It's extremely useful because, again, if the data is very noisy, forecasting models tend to have issues. So this usually, by varying the granularity, you can achieve a smoother data set, which can help in better forecasting. And of course, you can also look at time variation of metrics with different dimensions so that you can eliminate dimensions that are extremely correlated. This obviously time series queries, which are also very fast. The monitoring model input and output. This is being used already by some customers out there who use Druid. Typical approach here would be data streaming in from some kind of streaming pipeline, usually Kafka, getting into machine learning model. Predictions are made in real time, again goes out to Kafka, and then you can bring in both the predictions and the output into it and do all kinds of interesting analysis to figure out if there are anomalies. Typically, statistical type analysis, things like this helps you in identifying miscalibrated models. An example of anomaly detection here, where your output may look like something like this. To identify, anomalies in this kind of situation, you often have to look at different time periods, like shown here. Look back at arbitrary time intervals, and that Druid really does well with the time series queries. And generally, the idea is to find multiple needles in the haystack and look at each to eventually find out what is an anomaly. So this applying this both to model input and output really helps in making sure that machine learning models behave as they should. Model training is probably the most important part of exploratory data analytics, and model training are the two important reasons why customers use Druid and in the machine learning pipeline. And some thoughts here on this. One of the reasons you want to actually use Druid for is often you may have to extract small amounts of data from different time periods. So we want 1 day from this current week, 1 day from the previous week, 1 day from the week before that, and so on, to really form a training data set that captures all the patterns in the data. And then different granularities, especially this is true of forecasting data. I'll show you an example where training the model on a 1 day granularity forecasting is much less accurate than training it on a 1 hour forecasting, 1 hour granularity time series data. The other interesting thing is being able to look at different patterns and test your model against various patterns to see at what spot the model does well, what spot it breaks, and so on. And as I already discussed, genetic algorithms require lots of data points to be extracted. and test it for. And the most important thing that you imagine doing all of this, often with a team of maybe 100 data scientists concurrently extracting data for different time periods, different granularities, different statistics, different aggregates. Some may be doing your exploratory data analytics, and some may be focusing on your model training and so on. So that's what I mean. Think about that. While Druid does all this really well, and there are many other tools which can potentially do these things well with one query at a time. But the key capability of Druid here is that you're throwing a bunch of concurrent queries and doing demanding that all what I've talked about be done really well, and that's what Druid obviously stands out. The first demo here is using a clickstream dataset with 3 billion rows in Druid. I'm going to be using Imply's hosted offering called Polaris, which is a hosted offering for Druid. I'll look at brief exploratory data analytics using Pivot in this particular use case. The next demo, I want to show you EDA using a Jupyter Notebook. This is just for comparison of how this can be done also in Imply Pivot. Then I will look at show you how a regression model to predict conversion rates can be trained. Check the model accuracy on the complete interval, and check also the model accuracy on interval with a drop in conversion, and then retrain the model. So let's jump to the demo real quick here. So I'm going to go ahead and okay, share my full screen here. Okay, so let's go into log into Imply Clarity. This is Imply Polaris. So this is Imply Polaris. I got a cube here. Just a bunch of metrics and dimensions coming from Druid. Now, before I actually start the process of EDA, I just want to show what this looks like in terms of the data set. So let's take a quick one here. Let's do a quick count here of all the data. So I just want to talk about the scale of what we are trying to do model training on here. A quick query here. It's about 3.3 billion rows of data sitting in here. That's what I'm going to be using as a data lake for training this model. Going in here, I want to look at, so typically what's happening, this is clickstream data. And one of the key things you often want to look at clickstream is your conversion rate, where users are being converted from, people who just come to your website to actually paying subscribers. That's what you want to look at. And let's look at this as a function of time here. So you see some of things coming in. I'm quickly moving to a time window here. So if I look at a specific time window, one of the things I see is that there is a drop in my conversion. It's a bit time to look it up. Let me just go change this time window to something that I know there is a drop in the conversion. So I'm going to go ahead and do that. Let's change it. Here, let's do this. Type it back. Type it out. Okay, so this shows us the data for the time period. This is what I'm going to throw. So this, the whole idea is, can I use a model that will give me reasonably accurate prediction for this this drop in conversion? This is my scenario here. So I'm going to go ahead first, put in a few measures. Let's take a look at maybe I can add number of events and let's see, unique sessions. Put in the unique subscriptions, and of course, number of clicks. Now, do I see some pattern? Perhaps there is some disturbance around here at this point. There is some pattern also here, although it's not so distinct, but this perhaps is a bigger pattern here with this. This may give us some prediction. Well, let us see. Okay, now let's switch to the notebook I'm using to train this regression model here. So this is typical, just basically Jupyter notebook. So I'm just running a piece of code here with authentication to sign into Polaris, which is what I've done here. I'm going to go run this query, which essentially gets you those unique sessions, unique subscription, clicks, and the count itself. Right? So quickly, let's run this SQL query. Once SQL is run, I have this particular data frame already brought into this whole thing is in Apache Druid essentially. So I've got this data frame here. Let's quickly inspect it. That's what it is. I got the total, which is the count, then the unique session, unique subscription, click, and then the cumulative subscription. The cumulative subscription is what I am keen to look at because that's what I want to predict. Like I've got a few things doing, meddling with the data frame, extracting the attributes, and then the predictions, and then making sure, and then training a k nearest neighbor, a KNN model as a regression model in this case. Usually, KNN can be used for either classification or regression. In this case, I'm just using it for regression. Let's run this, and then we see a mean square error of less than 1%, right? So about 0.8%. So the model is pretty good. The question is, can this model actually predict this area? So what I then did, I got the data just for that time period where that drop actually exists. I'm going to quickly run this again, put the data in, and then so you can see I'm actually running the notebook. So you can see how fast the access is on the 3 billion rows. And so that's pretty obvious here. So again, run a KNN model here. You can see now the error has gone up to 4.2%, like from 0.8 to 4.2%. That's a huge change in the error just for that interval. Now, question is, can I get to a more better accuracy? What I'm going to do here is remove some of these measures, which are clearly not helping. So when I looked at the data, obviously the thing that's happening is users moving across to different states. So I can drop it here. You can see that the user is actually moving from multiple different states. The question I had was, can there be a better prediction when looking at whether users spend, how many users come to one particular state and then become subscribers? So that's an interesting question I had, and that's what I did by adding a few measures here, where I have home plus exit session, home and subscription, and home and content. So I had these three measures added up. You can see that they actually do have home subscription, and let me add the home content also. 4 measures on the subscription bit, and you can see that there are some really interesting patterns here, which make me think that in fact perhaps I could have a better prediction using those measures, and that's what I've done. I've run another query here where I'm using bringing in those measures. You see that I'm again training a KNN model on that. And again, if you see now the error is reduced from about 4.2% to 2.4%. Significant gain in accuracy by using a different set of metrics. And clearly, running these kind of queries is doable because I have Druid. I'm not running these on the notebook itself. So that using Druid along with Pivot, and then along with a notebook, a Python notebook, really makes things amazingly fast. So that's thinking about it. Okay, so let me go to the next demo real quick here. The next demo is on forecasting data from stock trades, right? So it's an interesting ARIMA model, but I'm doing the EDA completely in a Jupyter notebook instead of using Pivot for this particular use case. So let's take a look at that. So I'm not going to run this particular notebook again. It's similar to what I did, but also ARIMA models take longer time to train. Unlike this is not something to do it, just that forecasting models do take longer time to train. So I I'm getting some data from a database where I have multiple stock data. In this case, I'm getting ticker symbol TCS for a particular time period. And I'm first looking at what the data looks like by plotting the close value of the stock on that day against time. So it's done here. Then I try to look at sum of close. This is close for every. If you look at this, it's just raw data with what the millisecond timestamp that the data comes in. Now I have also then summed up the data by the day, and then I'm plotting it out here. And we get a smoother curve, and then a bunch of things like looking at correlation. So, for example, autocorrelation of 0.98 with or close with certain variables, and a bunch of other correlation analysis, and looking at how all these other features are correlated. These are pretty standard things you would do in this kind of model training. And really, this is not where you'll be using Druid directly. You just get the data into a notebook and do these kind of things. But once I'm done with that, the correlations, different types of EDAs, I decide to train an ARIMA model, and that's what I'm doing here. Now, here the interesting thing is, for the first time, I trained an ARIMA model with data that's aggregated to one day. So I went ahead and trained the model. You can see model training here, but the interesting bit here is this. So this is the prediction of the model. The test data actually looks like this. Your model is way off. So not very useful. So based on that, I thought, okay, what about if I change the granularity, right? So I went ahead and did a 6-hour interval here, and again trained an ARIMA model, which then gives me not so good. Then I went in for a 1-hour interval, and surprised that this thing gives me fairly much better model here, and get much more accurate predictions. So the key point here is that not that a particular interval gave me accurate better predictions, but the point is, because I have Druid, I'm able to vary the granularities fairly quickly in a very ad hoc way. Right? A query like this takes hardly, maybe a few seconds compared to how long this model takes to train. This may take a few seconds to execute and get you the data, but you can do this in a fairly ad hoc way. Now, remember, doing this even in raw Python, while it's possible, is somewhat challenging because you probably have to load up a lot of data set, or if you want to change the date, for example, you have to load an additional data set. So you keep doing that sort of thing, which is makes it very cumbersome. So this is the point I'm trying to make here. Okay, cool. So those are the two interesting demos. I had a third demo, which I'll just quickly do a show, because I'm pretty much running out of time here. I've trained in this case, a logistic regression model, so that here I'm trying to, in the same clickstream data set, I'm trying to predict whether gender, campaign, age, and channel can tell me whether a particular user will be a subscriber or not. Right. So that's what I did. Brought in the data set as usual from a query on Druid, trained a logistic regression model after converting everything to a categorical variable, removing all the infinites, etc., and got a accuracy of pretty much 100% accuracy, which is kind of suspicious, but this is demo data, so we'll have to kind of go with that. And then I again extracted only the time interval where there is that drop in subscription, and use that to test the model against that, and it seems to have performed pretty well again. So that's the quick take on the doing model training for model with categorical variables. Okay, so what we saw was 3 example models trained using data in Druid. We saw EDA done through both Imply Pivot and Jupyter Notebook, and being able to extract different time intervals to improve model accuracy, and ability to aggregate different granularities to reduce noise in your forecasting model. So the Druid's ability to do time series queries, to do different aggregations and do statistics on the fly, what make model training much faster, especially when you have data lakes that are petabytes in size. Okay, thanks. We have some time for Q&A, so please feel free to ask the questions. Thanks for attending the session.